Okay, how many of you have found the error in the warm-up yet? Raise your hand if you found it. It's a single error. There is one error. I'm going to give you guys one more minute, and then we'll talk about it. Okay, so you might recall one of the last couple of days, I don't remember exactly, I asked you guys in the main loop, what is it that draws your objects to the screen? In the main loop. Huh? Yeah, it's the window finish frame. So look in your code. Where is that window finish frame? Not in the main loop. It was before the main loop. It needs to be after it in order, or at the end of it in order to work. So that window finish frame line needs to move down after frames increments by 1. That was the one error. Okay? So window.finish frame needs to move from, I think it was on 27, it needs to move down to 34, needs to be indented, and then you need to hit submit. Okay? Now, excuse me, there are two things that I need to go over with you guys before I let you start working. The first one is the change image demo. Are y'all good? Tell me what you're working on. Okay. Okay. Oh, there we go. All right. I am going to go ahead and start with the change image. We're going to learn a new technique called change image. It'll help us make our sprites even more lifelike. So basically what you're doing with this is changing a sprite's image while the program is running. So, the first example I can think of is that maybe you have a still image that's moving across the window, and at some point you want to change the direction and move it the other way, or move it up. Maybe it's going in a maze, and what you need to do then is choose another image, but it's rotated differently. It's just an example, okay? But we use this when we have a sprite that we want to have multiple poses or appearances. It can be done with a static image and or a sprite sheet. So you could change it from a still image to a sprite sheet. You could change it from a still image to another still image. You could even change between two sprite sheets if you wanted to, okay? So using one sprite with different images is easier than creating different sprites to represent each appearance. So instead of creating more instances just to have a different pose, you create that one instance, that one sprite, and in the code you change the image attribute. The value of the image attribute is what you're doing, okay? So if we look here, you see a couple of images. This would just be an example. You have a frog in a normal frog pose, and you're telling me that you're going to be gone. Okay. Is this to Ms. Shoemaker? Okay. Okay. Thank you. And then at some point, you want to change it to this second pose, which is the frog leaping. Okay. Other examples might be a button, because typically if you look at a button, when it's clicked, it changes appearance. It makes it look like it's been pressed. Maybe a character's face changing, depending on what kind of emotions they're feeling. Or maybe a bird's wings flapping while they're trying to gain altitude, but then when they soar, you have a different one that goes in to where their wings just glide through the air. Let's go ahead and look at the program of the sleepy cat. So right now you have a cat, and all it is a still image, and it doesn't do anything. We need to change that. If you look at your project panel, you're going to see that you do have the cat idle, which is what's visible. You have a cat sleepy and a cat tired.png. Okay? So we have the setup, the sprites, the objects have been added. You have a sprite called cat, and now we have our while loop. And so in this while loop, we need to change our image. So I'm going to go to line 25, and I am going to say if frame equals, and that's a double equals 50, then cat.image equals, a single equals, cat tired.png. And remember that your file name needs to be exact. So if there's a capital letter, you need the capital letter. You also need the file extension. Okay? So what this is saying is that when you can see here in the main loop that the frames start at 0, and as it runs through the while loop, it's incrementing by 1. So when you get to 50 frames, which is, of course, as you know, less than 2 seconds, it goes and it kind of lays down tired. Well, we also can make it go to sleep. So if frame equals 100, we want cat.image to be cat sleepy.png. And then run it again. Okay, so when it runs, Little less than 2 seconds, it becomes tired. Less than, or now I don't remember, another 2 seconds, it falls asleep. Did everybody get theirs to work? Okay. So, here we have the syntax, the general syntax. And I do want to point out sprite.image equals pose1.png. So remember, we make our instance up at the beginning, and we give it a name, a variable name, an instance name, okay? So in this last one, it was cat. And remember that we have cat.image here, and it has the value here. So if cat is my instance name, what is .image? If cat is my instance name, .image is an attribute, and then the file name is the value. Okay? So you want to make sure that you keep that in mind. And then in your while loop, you have a if condition, and then your sprite.image changes to a different pose. That is your general syntax. Okay? So let me go. I'm not going to open up the two practices yet because I want to go over the planning. Let me show you tomorrow. You do have a warm-up, a lesson check, and then you'll have the code writing for this humming dart, which is what I'm going over right now. Okay? So with humming dart, let me open it up. All right, in humming dart, we're going to use the speed attributes of a sprite to help a bird find its way home. Whoops. So, how hard is it to land on Mars? Not that hard? Okay. So, the most recent Mars lander, InSight, set off for Mars in May 2018. How long do you think the flight was from Earth to Mars? Any ideas? Any guesses? A year? Anyone else? 10? Anyone else? How long did it take the InSight lander, Mars lander, to go from Earth to Mars? Never? All right. How about 7 months? 205 days. Okay? So how fast do you think the lander was traveling? How many of you drive? How many? Those of you that drive, what is the fastest you've driven your car? I won't tell anybody, I promise. 120? 115? Okay. So do you think at 120, how long would it take your car to get to Mars? If it could actually go that way. Any ideas? Probably something like that. Okay, so it traveled at 6,200 miles per hour. Okay. So during that 7-month trip, the team at NASA only had a handful of opportunities to make minor course corrections. If their initial calculations were off, the lander could fly right past Mars, lost to space for the rest of time. Fortunately, the InSight lander made it safely to Mars in November of 2018. So if NASA can calculate how to get landers onto Mars, we can certainly calculate how to help a hummingbird fly back to its nest. Not really? All right, so let me go here, and I'm going to run the solution. As I close the door. So, first I want to point out that each time you open this program, the hummingbird and the nest are in a different position, or could be in a different position, because they have random coordinates. So it says help the hummingbird get home, enter a horizontal speed. I'm just going to put in 10, and then my vertical speed, I'm going to make it, well, actually, no, I'm going to start that again because 10 goes really slow. 10 goes really slow. I'm going to say horizontal speed, I'm going to do 50, and vertical speed, I'm going to do less because it's not going that much vertical. So I'm going to say 20. Oh, shoot, I forgot negative. That would have worked too, I think. Maybe not. But anyway, it's not going. It's going to crash off the page. Poor hummingbird. Yeah. You don't think so? Okay, well, now I got to try it again. All right. This time, all right, horizontal speed 50, enter a vertical speed, was it? Oh, okay. Oh, I might get it. I might get it. Oh, get in there. Yes. All right. Okay. So that is what you are doing. So you have to help it get home. Start the bird and nest sprites at random positions. Let the user enter the bird's horizontal and vertical speeds. Determine if the bird lands in the nest using the distance formula. So you are going to have 3 libraries that you're importing: TS app, random because you're using random integers, and math because you got to find the square of the distance between the 2 x coordinates and the 2 y coordinates, and then you got to get the square root of the sum of those 2 values. Well, yeah, you have to put in some calculations so that it is about it. So, what is your input here? Yeah, the user puts in the horizontal and the vertical speed. What is the output? It moves, hopefully to the nest, right? So, what is the goal of this game? To reach the nest. You guys are on top of this. Okay. What controls the movement of the bird during the game? Yes. The X speed and the Y speed that the user inputs controls the movement of the hummingbird. Okay? You have to remember that. You don't control it as the coder. I mean, to a certain extent, but they really control whether it gets there. So you got to write your plan for the program in this area, okay? However, before you do that, let me go back to the lesson plan real quick. I am going to go to tomorrow's. I'm not unlocking it, but I am going to show you some code for just a minute so that you can see what it looks like. So like I said, you're importing 3 libraries. You get your sprites set up. You scale them. You have the bird, the tree, and the nest. You have a background, and then you have the positions. Notice that the X position of the bird is always 50 because it always starts over at the left-hand side. You're only randomizing the Y position of the bird. But the nest, within a specific range, gets both of them randomized. And then you have bird Y start equals bird.y. Remember that one. So then you're going to add some objects, and it has a finish frame here. And that's because you are helping the hummingbird get home. But then there is a while loop, and this is where you have to work on the speeds. So you have to have some if statements. If the bird's speeds do something, then you have to do something else. You have a finish frame there, and again, checking speeds. Then we have distance, okay? And your distance is going to equal the center x minus nest.center x. Whoops, hang on. Let me see if I can close that real quick. There we go, okay? And I'll help you guys with the formulas if needed. But there it is. Then you have another if statement checking on distance, and then you have another if statement checking on distance if it missed, and then you finish frame again. Okay, it's a bit in there, but you are planning it today and doing it tomorrow. I am unlocking change image 1, change image 2, and the lesson notes. If you need to go through your lesson notes to help you prepare for tomorrow's lesson check, please take the time to do that. If you're behind on things when you finish today, please work on that as well. Although if you don't finish these things today, you do need to take care of it tonight, because tomorrow should just be the lesson check and the code writing.